In this lesson, we shall write A as a product of an elementary matrix and an upper triangular matrix given the 3 by 3 matrix A with the first row 1, 0, -3, the second row 3, -2, and -3, the third row 0, 0, and -2. We present a solution to this problem in a step-by-step fashion as follows. Right now, first things first, we let AB 1, 0, -3, 3, -2, and -3, 0, 0, and -2. Right, and moreover, we're able to make the observation that this matrix must be reduced to an upper triangular matrix, and this means that we shall have the second row minus 3 times the first row, 1, 0, -3, and here we have a 0, -2, and here we get exactly -3 times -3, which gives us a 9 minus 3, giving us a 6, 0, 0, minus 2. We have exactly this particular matrix here. And this particular matrix here is actually the required matrix, which is the matrix in upper triangular form. Thus, we can call this matrix U. Thus, U becomes this matrix 1, 0, -3, 0, -2, 6, 0, 0, -2. And this one here is an upper. Right, is an upper triangular. Is an upper triangular matrix. Right, so now we continue to solve this particular problem, right, as follows. Now, the couple of things we need to take into account. Now that we're able to achieve this matrix, we want to then be in a position to obtain the upper triangular matrix, or rather the elementary matrix that is required. Right. So we have the following. We have the following. Right. So what then we have here is that we actually need to recall that the 3 by 3 identity matrix is given as follows. So we then say moreover I3 1 0 0 0 1 0 0 0 1. Right. So we continue as follows. We then say that at this point, this matrix can be transformed to an elementary matrix by applying one elementary row operation. And the elementary row operation is row 2 minus 3 row 1. Row 2 minus 3 row 1. 1, 0, 0. Row 2 minus 3 row 1, which is minus 3, 1, 0, 0, 0, 1, like so. Okay, right. We actually, therefore, have achieved an elementary matrix we can call E1. Okay, so now we proceed to solve this particular problem as follows, and then say, hence. Right, hence, we have the elementary matrix E1, which actually is 1, 0, 0. Right, and then minus 3, 1, 0. And then 0, 0, 1. Like this. Now at this point, we have this particular elementary matrix. And what is then the meaning of this here? Right, so hence we have that this is the elementary matrix that is obviously required. But now there's more to this. And what then do we have as a consequence of this? We note that, right, we note that we were initially given the matrix A, we applied this elementary row operation, meaning we got an elementary matrix, and that produced an upper triangular matrix. Right, using algebraic manipulations, we actually have E1 inverse U, E1 inverse E1A, E1A, which then means that you have E1 inverse U, which equals A, and this is exactly what we have as an elementary, as the elementary matrix inverse times U equals A. What then are we able to achieve out of this? Well, the meaning is that we then have, so this is the case, so that the matrix A is E1 inverse U, and E1 inverse U is actually therefore the product of an elementary matrix times an upper triangular matrix there. And this means that we've actually, if we're able to write A in this form, would have therefore been in a position to express A as a product of an elementary matrix with an upper triangular matrix. So what we then do right now is to consider the elementary matrix E1. Right. Right. So now we have the following. So let's consider this particular elementary matrix E1, which is 1, 0, 0, minus 3, 1, 0, and 0, 0, 1. 1, 0, 0, minus 3, 1, 0, 0, 0, 1. So that's E1, it's this. And we actually therefore proceed to attempt to find the inverse of this. We need to find the inverse of this elementary matrix, noting that the inverse of an elementary matrix is also an elementary matrix. So we're good. We're good. Row 2 plus 3, row 1. Right, we have exactly this here. Then we have a 0, 1, 0. 3, 1, 0, 0, 0, 1, 0, 0, 1. Like this. Right, so we therefore would have obtained, and we are able to then say, this is the case, so that we obtain, right? What do we obtain? We obtain a new matrix called E1 inverse, which is 1, 0, 0, 3, 1, 0, 0, 0, 1. Right, put a 3 here, like so. And this, obviously, the inverse of an elementary matrix is also an elementary matrix as well. Right, so therefore, the matrix A, we have already seen that, can be written as E1 inverse U. And what is E1 inverse? E1 inverse is actually the same as 1, 0, 0, 3, 1, 0, 0, 0, 1. It's actually 1, 0, 0, 3, 1, 0, 0, 0, 1. And what is then the upper triangular matrix? 1, 0, minus 3. 0 minus 2, 6. 0, 0 minus 2. Okay, so this therefore becomes the matrix A written as a product of an elementary matrix and an upper triangular matrix U. Right, now with this should be the answer to the problem. But we need to check. Let us check this. Let us check, is this correct or not? In other words, if A, we know very well it's the matrix 1, 0, negative 3. 3, negative 2, negative 3. 0, 0, negative 2. If that is the case, then we can be in a position to achieve the inverse of E1, which is 1, 0, 0, 3, 1, 0, 0, 0, 1, which is exactly the E1 inverse, and the upper triangular matrix U, which is 1, 0, negative 3, 0, negative 2, 6, taken exactly from here, 0, 0, negative 2. Right, so we have this. We have exactly this here, and so this is the upper triangular matrix minus 2 with a 6 here. And therefore multiply row by column, getting a 1 here, this by that, getting a 0, this by that, getting minus 3. This by that, getting a 3, this by that, getting minus 2, and this by that, getting exactly minus 9 plus 6, minus 3. This by that, getting a 0, this by that, getting a 0, this by that, getting negative 2. Okay, we have this. We have exactly that. We have exactly this here. We have exactly this here. We have exactly this. Now, we know, therefore, that after the multiplication of E inverse U, E1 inverse and U, we're able to get 1, 0, negative 3, which is the first row of A, and the second row is the same as the second row of A, and therefore, this confirms that the E1 inverse U is equal to the 3 by 3 matrix A, and therefore, it means we have been able to solve this problem. We have been able to express A, therefore, as a product of an elementary matrix and an upper triangular matrix, and we have therefore managed to solve this problem step by step. And it is, obviously the case, and obviously henceforth, right, henceforth, the matrix A can be written as E1 inverse U, right, E1 inverse U, which is exactly the same as, and we know that the E1 inverse is what? 1, 0, 0. Right, and also 3, 1, 0. 0, 0, 1. What is the upper triangular matrix? The upper triangular matrix is 1, 0, negative 3. 0, negative 2, 6. 0, 0, negative 2. So with this, then, we say we've been able to write A as a product of an elementary matrix and an upper triangular matrix, and we have solved this problem step by step, and it is awesome, awesome news that we done. Thanks everybody for watching, and goodbye to you.